In the 1999 National Electrical Code, Section 210.11 Cone allowed a 15-amp circuit for what was termed other bathrooms. This specific provision was officially removed in the 2002 National Electrical Code and has not been reinstated in any subsequent editions. What this means is that the allowance for a 15-amp circuit in certain bathrooms is no longer valid. The current National Electrical Code, specifically Section 210.11 Cone, mandates that all bathroom circuits, irrespective of the number of bathrooms in a dwelling, must now be served by a 20-amp circuit. To understand the implications of this change, let's delve into the requirements and reasoning behind it. The National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Section 210.11 of the NEC deals with branch circuits required in dwellings. Branch circuits are the circuits that extend from the panel board to the various outlets and devices throughout a home. Subsection C of Section 210.11 specifically addresses bathroom branch circuits. The key takeaway is that the current code requires a minimum of 120-amp branch circuit to supply the bathroom receptacle outlet or outlets. This requirement applies to all bathrooms within a dwelling unit. Now, let's explore some of the reasons behind the code change that eliminated the 15-amp circuit allowance. Firstly, the increasing use of electrical appliances in bathrooms has placed a greater demand on electrical circuits. Items such as hairdryers, curling irons, and electric shavers often draw a significant amount of current. A 15-amp circuit may not be sufficient to handle the combined load of these appliances, especially if multiple appliances are used simultaneously. Overloading a circuit can lead to overheating, which in turn can create a fire hazard. Secondly, ground fault circuit interrupters, or GFCIs, are now required for all bathroom receptacles. GFCIs are designed to protect people from electric shock by quickly interrupting the circuit if a ground fault is detected. The use of GFCIs has become more prevalent over the years, and they are an essential safety feature in bathrooms where water is present. A 20-amp circuit provides a greater margin of safety when used in conjunction with a GFCI. Thirdly, the code change simplifies the wiring process by eliminating the need to differentiate between other bathrooms and those requiring a 20-amp circuit. This reduces the potential for confusion and ensures that all bathrooms are wired to the same safety standards. To further clarify the requirements, let's consider some specific scenarios. If a dwelling unit has multiple bathrooms, each bathroom must be served by at least one 20-amp branch circuit. It is permissible to have multiple receptacle outlets on a single 20-amp bathroom circuit, as long as the total load on the circuit does not exceed 80% of the circuit's rating. This means that the total load should not exceed 16 amps on a 20-amp circuit. In addition to the receptacle outlet or outlets, the 20-amp bathroom circuit can also supply other electrical equipment within the bathroom, such as lighting fixtures and exhaust fans. However, it is important to ensure that the total load on the circuit does not exceed the 16-amp limit. It is generally recommended to avoid connecting other rooms or areas to the bathroom circuit. The bathroom circuit should be dedicated solely to the bathroom to prevent overloading and ensure that the GFCI protection is effective. If a bathroom has a whirlpool tub or other high-demand appliance, it may be necessary to provide a separate dedicated circuit for that appliance. The manufacturer's instructions for the appliance will specify the required circuit size. When installing or modifying bathroom circuits, it is essential to follow all applicable National Electrical Code requirements. This includes using the correct wire size, properly grounding all electrical equipment, and installing GFCIs for all receptacle outlets. It is also important to obtain any necessary permits and inspections from the local electrical authority. Failure to comply with the National Electrical Code can result in unsafe conditions, electrical hazards, and potential legal liabilities. It is always recommended to consult with a qualified electrician for any electrical work, especially when dealing with bathroom circuits. A licensed electrician has the knowledge and experience to ensure that the work is done safely and in accordance with the National Electrical Code. In summary, the National Electrical Code no longer allows 15 amp circuits for any bathrooms. All bathrooms must now be served by a 20 amp circuit as per section 210.11 Cohen of the current National Electrical Code. This change was made to improve electrical safety and accommodate the increasing use of electrical appliances in bathrooms. When installing or modifying bathroom circuits, it is essential to follow all applicable National Electrical Code requirements and consult with a qualified electrician. This will help to ensure that the work is done safely and in compliance with the latest standards. The rationale behind the change from allowing 15 amp circuits in some bathrooms to requiring 20 amp circuits in all bathrooms is rooted in several factors primarily related to safety and increased electrical demand. Firstly, appliance usage. Modern bathrooms often contain a variety of electrical appliances such as hair dryers, curling irons, electric shavers, and even small space heaters. These appliances can draw significant amounts of current, and the combined load for multiple devices operating simultaneously can easily exceed the capacity of a 15 amp circuit. This can lead to overloaded circuits, trip breakers, and potentially dangerous situations such as overheating and electrical fires. Secondly, ground fault circuit interrupter or GFCI protection. GFCIs are now a standard safety feature in bathrooms, designed to protect against electrical shock by quickly detecting and interrupting ground faults. While GFCIs enhance safety, they also require circuits with sufficient capacity to handle the momentary surge that can occur during a ground fault event. A 20 amp circuit provides a greater margin of safety in these situations, ensuring that the GFCI can function effectively without causing nuisance tripping or compromising protection. Thirdly, code simplification and consistency. The previous allowance for 15 amp circuits in other bathrooms created ambiguity and complexity in the National Electrical Code. Electricians had to determine which bathrooms qualified for the exception, leading to potential errors and inconsistencies in wiring practices. By requiring 20 amp circuits in all bathrooms, the National Electrical Code simplifies the requirements, eliminates confusion, and ensures a consistent level of safety across all bathroom installations. Fourthly, future-proofing. Electrical codes are designed to anticipate future needs and technological advancements. As new and more powerful electrical appliances become available, the demand on bathroom circuits is likely to increase. Requiring 20 amp circuits ensures that bathroom electrical systems have sufficient capacity to accommodate future loads without requiring costly and disruptive upgrades. Fifthly, safety margin. A 20 amp circuit provides a larger safety margin compared to a 15 amp circuit, reducing the risk of overloading and overheating. This is particularly important in bathrooms where water is present, increasing the potential for electrical hazards. The additional capacity of a 20 amp circuit helps to minimize the risk of electrical shock and fire. To summarize, the transition from allowing 15 amp circuits in some bathrooms to mandating 20 amp circuits in all bathrooms is driven by a combination of factors, including increased appliance usage, the need for reliable GFCI protection, code simplification, future-proofing, and enhanced safety. This change reflects the National Electrical Code's commitment to improving electrical safety and ensuring that electrical systems are adequate to meet the demands of modern living. When working with electrical systems, it is always recommended to consult with a qualified electrician who is familiar with the latest National Electrical Code requirements and best practices. A licensed electrician can assess your specific needs, design a safe and efficient electrical system, and ensure that all work is performed in accordance with applicable codes and regulations. Let's also consider some practical implications of this code change. For existing homes that were wired with 15 amp circuits in some bathrooms prior to the 2002 National Electrical Code, it is not typically required to upgrade those circuits to 20 amps unless renovations or modifications are being made to the electrical system. However, if you are experiencing frequent tripping of the 15 amp circuit breaker, or if you plan to use multiple high-demand appliances in the bathroom simultaneously, it may be advisable to upgrade the circuit to a 20 amp circuit for improved safety and convenience. When upgrading a circuit from 15 amps to 20 amps, it is important to ensure that the wiring is also upgraded to the appropriate size. The National Electrical Code specifies the minimum wire size for different circuit ratings. For a 20 amp circuit, a minimum of number 12 American wire gauge, or AUG, copper wire is typically required. It is also essential to replace the 15 amp circuit breaker with a 20 amp circuit breaker. Never replace a circuit breaker with a higher rated breaker without also upgrading the wiring, as this can create a fire hazard. If you are unsure about how to upgrade a circuit safely, it is always best to consult with a qualified electrician. In addition to the 20 amp circuit requirement, the National Electrical Code also specifies other requirements for bathroom electrical systems, such as the placement of receptacle outlets and the type of wiring methods that are permitted. Receptacle outlets must be installed within 36 inches of the outside edge of each basin. All receptacle outlets in bathrooms must be GFCI protected. The wiring methods used in bathrooms must comply with the National Electrical Code requirements for wet locations. This typically means using moisture-resistant wiring such as type NMB cable or installing the wiring in conduit. By following these guidelines, you can ensure that your bathroom electrical system is safe, reliable, and compliant with the National Electrical Code. Remember, electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. Taking the necessary precautions and following the National Electrical Code requirements can help to prevent electrical hazards and ensure the safety of your home and family. Furthermore, let's discuss some common misconceptions about bathroom electrical circuits. One common misconception is that a 20 amp circuit can handle any number of electrical appliances. While a 20 amp circuit has a higher capacity than a 15 amp circuit, it is still important to avoid overloading the circuit. The National Electrical Code limits the total load on a circuit to 80% of the circuit's rating. This means that the total load on a 20 amp circuit should not exceed 16 amps. If you plan to use multiple high-demand appliances in the bathroom simultaneously, it may be necessary to install additional circuits to avoid overloading the existing circuit. Another misconception is that GFCIs are only required for receptacle outlets near water. While it is true that GFCIs are required for all receptacle outlets within 6 feet of a sink or shower, they are also recommended for all receptacle outlets in bathrooms regardless of their location. GFCIs provide an extra layer of protection against electrical shock, and they are a valuable safety feature in any bathroom. A third misconception is that it is acceptable to use extension cords in bathrooms on a permanent basis. Extension cords are intended for temporary use only, and they should not be used as a substitute for permanent wiring. If you need additional outlets in your bathroom, it is best to have a qualified electrician install them. Using extension cords on a permanent basis can create a fire hazard and increase the risk of electrical shock. In addition to the technical aspects of bathroom electrical circuits, it is also important to consider the aesthetic aspects. Receptacle outlets and switches should be installed in a location that is convenient and accessible but also aesthetically pleasing. Cover plates should be chosen to match the decor of the bathroom. Lighting fixtures should be selected to provide adequate illumination without creating glare. By paying attention to both the technical and aesthetic aspects of bathroom electrical systems, you can create a space that is both safe and functional. Remember, the National Electrical Code is a complex and evolving set of standards. It is always best to consult with a qualified electrician to ensure that your electrical system is safe, reliable, and compliant with the latest requirements. A licensed electrician can provide valuable advice and guidance on all aspects of electrical work, from circuit design to appliance installation. The increased use of electronics and appliances has led to the National Electrical Code mandating 20 amp circuits. It's not just about hair dryers anymore. We're talking about electric toothbrushes, sophisticated vanity lighting, and even entertainment systems being integrated into bathrooms. All these things contribute to the higher demand for electricity. Then, there's the issue of safety and future-proofing. The NEC aims to create electrical installations that are not only safe today but also capable of handling future electrical demands without requiring extensive modifications. Using 20 amp circuits from the outset provides a buffer for future upgrades and ensures that the electrical system can handle increased loads without becoming a safety hazard. The removal of the other bathrooms exception simplifies the code and reduces the potential for misinterpretation. Now, every bathroom is treated the same, which streamlines the wiring process and reduces the risk of errors. This consistency is crucial for ensuring uniform safety standards across all residential electrical installations. Finally, think about the impact on older homes. While you might not be required to rewire your entire house to meet the latest codes unless you're doing renovations, understanding these changes is still important. If you're adding a new bathroom or significantly upgrading an existing one, you'll need to bring the electrical system up to current standards, which means using 20 amp circuits. The code changes reflect the evolving needs of modern households and the increasing reliance on electricity. In summary, the move to 20 amp circuits for all bathrooms is about safety, convenience, and future-proofing. It addresses the increasing electrical demands of modern bathrooms, simplifies the code, and ensures a higher standard of safety for everyone. So, while it might seem like a minor change, it has significant implications for the way we design and wire our homes.